Hello honors pre-calculus students, this is Mr. Cazzato, and today we want to take a look at transformations of graphs. We did this in the Desmos. So the picture on the left is f of x, and the graph on the right is g of x. And our goal is to write the function g of x in terms of f of x. So you can focus in on the blue point. If you prefer, you could focus in on the green point. You could focus in on the yellow point, which is the open circle. Or you could focus in on the green point, whichever your preference is. So when you look at these two graphs, it doesn't look like there is a horizontal stretch or compression. So I'm just going to focus in on the open circle. This point is 1, 2, 3, 4, 5, 6, so 0, 6. And this point is 1, 2, 3, 1, 2, so negative 3, 2. So what happens to the function on the left to the function on the right? It looks like the graph is shifted over 3 and down 4. So that means g of x would be equal to f of x plus 3 minus 4, since it is shifted left 3 and down 4. What I'm going to ask you to do is take a look at number 2, pause the video, and see if you can write the function for problem number 2. Okay, problem number 2. The function is g of x is equal to f of x minus 2 plus 4. If I were to focus in on the open circle again, we have the point 2, 1, 2, 3, 4, 5, 6, it looks like. And this new point 1, 2, 3, 4, 1, 2, 3, 4. Looks like 4, 10. So again, it doesn't look like there's a horizontal stretch, horizontal compression, or a vertical stretch or vertical compression. So when I look at this particular graph, it looks like it has moved up 4 and over 2. So that's the function g of x you should have came up with. All right, problem number 3. Take a look at problem number 3. See if you can come up with the function. Again, pause the screen. All right, in problem number 3, if I were to focus in on this yellow dot, looks like there is a reflection. So right now I'm at 1, 2, 3, 4, 5, 6. I'm up at 0, not 0, 6, 2, 6, 3, 6. It looks like we're at 3, 6 there. So if there's a reflection, I'd be at 3, negative 6. So 1, 2, 3, 4, 5, 6. I'd be at that little x. So it looks like there's a reflection, and then this yellow point on g of x is 1, 2, 3, 4, 5, 1, 2, 3. Looks like 5, negative 3. The x is sitting at 3, negative 6. So it looks like the graph then is shifted after the reflection over the horizontal axes. Looks like it is shifted to the right 2 units and up 3. So for problem number 3, g of x is equal to negative f of x minus 2 plus 3. So the negative in front reflects the graph over the horizontal axes, and then it's shifted right 2 and up 3. Okay, take a look at problem number 4, and go ahead and pause the screen and write your answer for problem number 4. When you're done, come back. Okay, hopefully you wrote the following answer for number 4. G of x is equal to negative f x plus 3 minus 2. And let me just quickly go through that one. So if I focus in on the open circle again, it does look like there is a reflection. For clarity, you could focus in on any of the points on the graph, and there are infinitely many. So that yellow circle is 1, 2, 3, 4, 5, 6, 0, negative 6. So if you reflect it, you'd be at 6. So I'm going to put this on the other graph. So 1, 2, 3, 4, 5, 6. So you'd be up at that x with the reflection. And then it looks like it moves over 1, 2, 3, and down 2. So that's why it's x minus 3 in the parentheses, excuse me, x plus 3 in the parentheses, then minus 2. Okay, problem number 5. Take a look at this problem. Okay, so problem number 5, it looks like there's some type of stretch or compression. If I were to look at this green section, It looks a little longer. Same thing with like this yellow section here, and same thing with the blue section. So there's definitely some type of stretch or compression in here. So when I look at problem number 5, if I were to look at just a little yellow section, the horizontal distance is 2 between those 2 points, and the vertical distance is 2. In the graph on the right, the horizontal distance is 2 and the vertical distance is 4. So when I look at this, the horizontal distance does not change, but the vertical distance is changing. The vertical distance is changing from 2 to 4. So I'm going to put this little right triangle in there to make it a little more obvious. So hopefully you see that the vertical distance is changing. So there's a vertical stretch by a factor of 2. The other thing that I kind of notice is the point is reflected over the horizontal axes. So right now I'm sitting down here at 0, -4. If I reflect it over the horizontal axes, I'll be up at 1, 2, 3, 4 at this little X there. And then to get to the point that's on the graph, we stretched it by a factor of 2, so then we'd be up at 8. And 1, 2, 3, 4, 5, 6, 7, 8. This point is 0, 8. So it looks like this function g of x is equal to -2 f of x. So we can see the reflection and then a stretch by a factor of 2. Okay, pause the screen and try problem number 6. Okay, so for problem number 6, let's take a look at it. Again, I'm going to focus maybe just on this yellow dot there. So that yellow dot, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So we're at 4, 6. And then you can kind of see the yellow dot on the function g of x. So it looks like there's some type of reflection. Again, I'm going to make sure that the stretch is a constant of probably 2 or 3 most likely, but let's take a look at it. So if I were to look at this little green section here, in this green section, the horizontal distances are 4 on each of these. So we're going 4 over on each of those. So there's no horizontal stretch or compression. The vertical distance is 2. Here the vertical distance is 4. So again, there is a stretch by a factor of 2 vertically for problem number 6. Looks like there's also a reflection. So if I were to take this blue point that I'm highlighting 4, 6, stretch it by a factor of 2, and reflect it, I will be down at 4, -12, which is off the graph, which is right around here, 4, -12. This point on g of x looks like it's 4, -10 if I were to count. Therefore, it looks like it was shifted up 2 units. So g of x for number 6 is -2 f of x plus 2. Okay, number 7. Take a look at this problem. Try that on your own. The answer to number 7, g of x, is equal to 2 f of x plus 2. So if you stretch this point by a factor of 2, and then you have to move it left 2 units. So you stretch it by a factor of 2. Right now you're at -2, you'll be down at -4 where this little x is, and then you have to shift it left 2 to get the point correct. Okay, problem number 8. Go ahead and try to answer this question. Okay, so for problem number 8, the answer is g of x is equal to -2 f of x plus 1 plus 8. And let's talk about how we came up with that. So if I were to focus in on the yellow dot again, it looks like there's some type of reflection. If I were to look at this little green segment and this green segment, the horizontal distances are the same, but the vertical distance here is 1, 2, 3, 4. The vertical distance on this other one is 1, 2, 3, 4, 5, 6, 7, 8. So that's a vertical stretch by a factor of 2. It also looks like it was reflected. So right now this point is 0, 1, 2, 3, 4, 5, 6. So if you were to reflect it, you'll be at 0, negative 12. And then to get to the yellow dot, you're going to have to move it over 4 and up 8. So that's how I came up with the function g of x. Right, go ahead and try number 9. Okay, the answer to number 9, g of x, is equal to 3f of x plus 4 plus 8. Let's take a look at how we came up with that. So if I were to look at this green piece and this green piece, I really can't tell how long the green piece on the right is. So let's use this yellow piece and this yellow piece. The vertical distance, this is number 9. The vertical distance is 1, 2, 3, 4. The vertical distance over here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So because that vertical distance is 12, it looks like there's a stretch by a factor of 3. So that's how I came up with the 3 in front of the function f. So if you stretch it by a factor of 3, then you have to figure out kind of what happens thereafter. So I'm going to erase some of this on the left-hand side. So right now we're at 2, negative 2. If you stretch it vertically by a factor of 3, you'll be at 2, negative 6. So you'll be at this blue x. And then you have to get to the point, let me do some erasing here, you have to get to this yellow dot. So how do you get from the x to the yellow dot? You move left 4 and up 8. So that's how I came up with that function. Okay, problem 10. Take a look at it. Hopefully visually you see that there's some type of horizontal stretch or compression here, and it's actually a horizontal compression. You can tell that if you look at this green segment and this green segment, the vertical distances are the same, but this distance is 1, 2, 3, and this distance is 1. So there's a horizontal compression by a factor of 1/3. So for number 10, g of x is equal to f of 3x. I don't think there's a shift here, because if you take a look at this point, 1, 2, 3, 1, 2, 3, so this point is 3, 3. If you compress it by a factor of 1/3 horizontally, you'll be at 1, 3, which is the correct dot. So there's no shift on that one. All right, last problem on this one. Take a look, pause the screen, and try this problem. All right, so for number 11, g of x is equal to f of 2x plus 6. So just real quickly, this horizontal distance is 2, that horizontal distance is 1, so I know there's a horizontal compression by a factor of 1/2, so that's going to get me this value of 2. So you compress by a factor of 1/2 horizontally. So if I look at the open circle again, I got 1, 2, 3, 4, 2. If I compress it by a factor of 1/2 horizontally, I'll be at that little x, so I'll be at 2, 2. And when I look at the point here, we're at 2, 1, 2, 3, 4, 5, 6, 7, 8. So what do I have to do with this x? I got to move it up 6 units. So hopefully you found this helpful in terms of transformations. We're going to post an extra worksheet for practice